Good afternoon. Welcome to this session. A couple of reminders. Please make sure you submit your feedback for this session directly in the app. And if you would like the slides after the presentation, you can scan your badge at the front of the room. At this time, I would like to welcome to the stage Andy Karandikar and then Santosh Devaraju from VMware presenting on VMware Cloud on AWS.
Thank you. Super excited to be here. So my name is Andy. I lead the cloud pre-sales team for VMware. Later, I'll have Santosh join me. We're going to do a quick walkthrough of VMware Cloud on AWS, what it is, what's the value proposition, and towards the end, we'll give you a quick demo. So hybrid cloud is a reality, right? Most organizations are realizing that it's not all private, it's not all public, and depending on which analyst that you look at, most predict that enterprise organizations are going to land up at a 60-40 or a 40-60, depending on the sector that you look at. Can I get a raise of hands in the room? How many people have used VMware tools or VMware technologies? See quite a few set of hands. That's awesome. VMware is known and trusted to be an enterprise technology for running mission-critical workloads. In fact, in most enterprise organizations, including public sector, about 80 to 90% of the workloads run on VMware. It's estimated there's more than 70 million of these workloads that are running on-prem. Now, a lot of these same organizations are recognizing that there is a tremendous value in moving to the public cloud for elasticity, for innovation, for scale. And yet, these same organizations have had a lot of challenges moving to the public cloud. Not for lack of effort, but it's really tough. When I meet customers, I ask them this question, how is your migration going? And almost in all cases, customers share it's challenging, it's slow. Just a customer a few weeks ago, they had a plan to migrate over 150 workloads in 18 months. And today, just a few weeks ago, they've been able to migrate less than 10. Why is that? Well, if you have been running these environments in your traditional data center, you know the reasons. It's not easy. These applications cannot be just lifted and put into the public cloud. Take a simple example. If your traditional application, if you put it into the public cloud, would it be able to sustain if its IP address changed when it's put into a multi-AZ environment? Several applications cannot tolerate that. In addition, you have to do a format conversion. Then it's not just the workload or the application. There is an entire ecosystem that goes around these applications. It's your monitoring, it's the backup, it's the scripts, the enterprise SLAs, all of this, which has been an established environment, established ecosystem on-prem, becomes very hard just to lift and shift into the public cloud. What would happen at 2 a.m. if you get a call? Would you be comfortable? Do you have the right set of tool books, the run books, and the skills and the people to be able to manage that? This is exactly why, oops, sorry about that. Based on customer demand, the number one provider of public cloud and the number one platform for private cloud, that's VMware, essentially came together because of customer demand to create the best hybrid cloud offering. VMware Cloud on AWS is a co-engineered offering between VMware and AWS. We started this journey in 2016 and have invested thousands of engineers onto this platform. Now, look at some of the challenges, right, that we spoke about earlier. The lack of consistency, if you were to move them from private to public. Challenges with skill sets, challenges with enterprise SLAs. And you can't just take this application and put it straight into a public cloud. Even if you wrote new applications, they have to rely on existing set of applications and databases. This is what that offering looks like. So let me walk through this diagram a little bit. What you see in the middle block is VMC on AWS, that is VMware Cloud on AWS. In very simple terms, this is vSphere run as a service. In a little more detail, it is VMware SDDC consisting of compute, that's vSphere, networking, NSX, vSAN, as well as the management portfolio running natively on AWS within the AWS data center. On the left, you see your traditional data center. And then on the right is the AWS cloud. All of this integrate and work with each other in a very seamless way. I want you to pay attention to 3 arrows that you see, the horizontal arrows. Those are actually very important. The first one on the top left is the hybrid link mode, which gives you a single pane of glass, the VMware that runs on-prem to the VMware vCenter that runs in VMC is essentially the same thing. It's a single pane of glass, and you'll later see this in the video, in a demo. The arrow at the bottom left, that's HCX. This many customers call as magic. This is included with VMC service. This gives a very efficient migration of the workloads that run on-prem to the cloud and in the reverse direction if needed. And then the arrow on the right bottom, this is where the workloads that have moved to the cloud have direct access through cross-ENI connection to native AWS services. So as you accelerate your workloads into the cloud, you are able to then modernize and take advantage of all the cloud-native services. So what are the typical use cases on VMC on AWS? The most common one is data center evacuation. It's essentially customers who want to get out of their data center, and this could be specific to an application or because their data center lease is coming up for renewal. A good example of this is Stagecoach in UK, who migrated their mission-critical application, one that needs to be updated every 30 seconds in a high availability environment without downtime. Without downtime, the entire application moved from on-prem to the public cloud without impacting the business. Amazing. Using an innovation from VMware and innovation from AWS, using stretch clusters across multiple AZs. Right now, we are in the process of helping a healthcare organization in India do a migration. They're getting off of 2 of their data centers in a matter of 6 weeks. Think about this in your environment. How is your migration going? How long have you been working on migrating your workloads and modernizing them and putting them into a hybrid public cloud environments? Let's look at the second use case. The second use case is data center extension. This is where you already have an existing set of workloads and you need excess capacity. And this may be because of seasonal workloads. This may be because you are trying to leverage new types of use cases. Playtika, a gaming company, they were running into pressures on their production environment. What they did was they took their test and dev workload, which had a lot of variability, moved it off of the on-prem data center into the cloud, creating excess capacity for their production workloads. And once those test and dev workloads were in the cloud, they are now able to leverage the cloud-native services. An awesome win-win. The third common use case that we see is DR, disaster recovery. And this could be either a brand new DR or extending your existing DR or creating a completely new one. There are several examples of this. PHH Mortgage completely moved their DR into VMware Cloud and AWS. The example that I like even more is Lansing, who not just did this, they were very skeptical, but they moved this literally in a matter of 2 weeks. But what they found was their DR platform, the one on the cloud, the one on VMC, was running a lot more efficiently, giving them higher performance. Over the next few weeks, they actually swapped. They converted their production workload to be on VMware Cloud and AWS, and their on-prem became their DR. And then the last common use case is next-generation applications. Like I said before, building these applications, as you build new-age applications, these are not standalone applications. You need to rely on existing set of databases, an existing set of applications. And creating a co-resident model becomes very, very powerful. Here are some examples of applications that are good candidates for moving on to VMware Cloud on AWS. As you can see, each of these applications has very high performance and security requirements. But if you ask me, at the end of the day, is it just these applications? It's practically every workload, every enterprise mission-critical workload that runs on VMware on-prem is a candidate for moving into VMC on AWS. Now, this is a very powerful slide. Let me spend a few minutes on this. This story gets the CFOs really excited because it's what VMC brings to the table is acceleration of moving to the public cloud. Now, there are two graphs here. The one in yellow is how most traditional migrations go, right? They start with a story. There is a particular cost, and then there is a TCO, total cost of ownership or total cost of operations, And then they say, if we do this migration right, our TCO is going to come down by 30 to 40%. And that's great, right? There are many ways to look at this data. Practically, what happens, though, is these migrations take time. And while that migration is going on, the customer is paying dual costs, is paying the cost of running the infrastructure on-prem as well as running the infrastructure in the public cloud. And if you recognize, just look back at your organizations, look back at that example I said earlier, ask the customer how is your migration going. Most migrations are complex and long and get delayed, which means what you see on the right-hand side, that graph keeps getting extended. And as that keeps getting extended, the cost keeps high, right? So the yellow line is your cost is actually much higher before it can come down. VMware Cloud and AWS changes that story, and this is that becomes very exciting for CFOs. The blue line is what that line moves to the left. Because you can literally move these workloads, lift and shift in days, in weeks. You're shrinking the migration window because there is no change to your application, right? You quickly move to the public cloud, and then once you have migrated, you can start modernizing. You put the money back into your pocket to start funding your future projects. So this is a real benefit for the organization by lowering the risk for the operators, for the applications, as well as for the business. A real example is there's a large customer who started with a similar journey. They had about 200 applications, and they had estimated that it was going to cost them about $1 million to migrate each of those applications to turn them into cloud native, right? And they had about 200 applications, 9 months and $1 million per application. Even if they did a lot of parallel work, it would have accounted to about $200 million and 36 months to do that migration. And that was just on paper, not before execution, as most migrations would actually go longer. VMC, in their words, was sent from heaven. They are now able to migrate all of those workloads in a matter of 4 months, so 36 months versus 4 months, at a fraction of the cost. So this is real. This is not on paper, right? Customers are taking advantage of this to accelerate their journey to the hybrid cloud. So in short, the benefits are awesome, right? Live migrations, your workloads do not change. Your business does not get impacted. You get direct access to AWS native services. You keep your existing management tools and skill sets. And because this is applicable for a wide range of workloads, 80 to 90% of enterprise mission-critical workloads running on VMware, all of these become very strong candidates for leveraging the VMC platform. And here is the best part. This is not software. This is a service that is engineered, built, run, and supported by VMware, by the same set of folks who build the software, are responsible for making sure that this service is run with an SLA, is making sure that the software updates, the patches, the upgrades are done in a seamless way. Now think of how this is done on a traditional on-prem environment. Ordering new hardware, waiting for the PO, waiting for receiving, then racking and stacking, setting up the hypervisor, setting up networking if you have NSX, vSAN. Just think of, if you have done this before, it's a multi-week exercise, if not multi-month. In case of VMware VMC on AWS, it's literally press of a button. You press a button or make an API call, and within 90 minutes, 90, you have a full cluster, SDDC cluster running. Another 12 minutes, 10 to 12 minutes to add a new host. VMware is responsible for doing host remediation. If something goes wrong with a host, we are responsible for replacing the host, right? The conversation changes from managing software, installing software, deploying software, to really just worrying about everything about the hypervisor. And because it's run as a service, we keep up with the versions. The version upgrades are done every 3 to 6 months, even before they become generally available to rest of the customers. It's a fantastic value proposition. Now, obviously, it's a service, so we have to keep up with certifications and compliances. I'm not going to read what's on the screen. We follow lot of what AWS platform already has in place. Everything from ISO to various SOC to GDPR, and then the various regional compliances. Right here in Singapore, we're working on MTCS and OSPAR and all the set of certifications. But at the end of the day, this becomes something that is available as a platform for our customers. Global expansion and reach, right? So this is just a natural benefit of leveraging this in the public cloud, because you essentially just get to leverage everything that comes with AWS. We saw something interesting with the recent protest happening in Hong Kong. We saw one of the customers actually wanting to deploy their workloads in Singapore, right? Some of these options were just not possible for them when they were running this on-prem. So I want to spend a couple of minutes on HCX. HCX is a very cool technology. Our customers call it magic when they see this in action. And we're going to show you a quick demo of how this works. HCX is an extension that is available with VMC. It's included as part of VMC. At the end of the day, it's a cloud service. It's an appliance that gets deployed. It operates as an orchestrator. It creates a plan for you to migrate your workloads in bulk. So you can tell it to say, migrate these out of these 1,000 workloads, migrate them at 100 workloads over every weekend, right? And you can give it special instructions around how to change, how to manage IP addresses, and special requirements around connections to which types of servers in the cloud and on-prem, and the thing just works like magic. Brinks, which is the security company in the US, they migrated 300 of their workloads over just one weekend. A few hours to set up HCX, and then just a weekend to migrate 300 workloads. It's pretty amazing. So I'm going to close it here. Just a quick summary. Consistent infrastructure, consistent operations, ability to truly accelerate your migration to the hybrid cloud so that you can put money back into your pocket without impacting your business, without impacting the operations team. And then putting you in a place which gives you access to all the innovations on the AWS platform. With that, I'm going to invite Santosh to join me on stage. We're going to do a quick demo of what the VMC service interface looks like to get you to see what that single pane of glass. It's actually going to be underwhelming. It is vCenter, whether you see it in the cloud or on-prem. And then we're going to try and do a quick demo on HCX Live Migration.
Hey, Andy, before you go, I have a quick question for you.
Go ahead.
Does it feel amazing to have AWS, VMware under the same roof? Like 3.5, 4 years before, like you were fighting each other. I mean, how exciting is it, right?
I should probably ask that question to the audience. This is, by the way, driven by customer demand, right? If you just go back 4 years ago, VMware and AWS were hard competing in the market. But our customers told us that the two top players, the top #1 in public and #1 in private, really need to come together because hybrid is the future. And this is the reason why this offering was created. It is fantastic to be under the same roof, talking the same language for customer benefit. Awesome. Amazing.
That's a great thought. I mean, we feel very excited to work together because, you know, together, there's a lot of possibilities. The reason because, as Andy mentioned, 85% of the workloads that are running on premises are running on VMware, and we can go together and provide the quickest possible way to move the workloads to VMware Cloud on AWS and give you the privilege and the right to use the infinite scale of resources available on AWS. Right? So without further ado, I'm going to run a quick demo. Should not take more than 8 to 10 minutes. So this is my VMware Cloud on AWS SaaS portal, right? So this is the admin portal. So do not get really confused that, oh, so there's no more vCenter, right? So vCenter is still there. That's still the critical part of managing your workloads. But this is the portal where you're going to come and create VMware Cloud on AWS clusters, right? So again, whenever customer asks about, okay, so this is something running on AWS. Yes, we are using AWS data center, but we are not running on the nested virtualization or anything, right? So we are leveraging AWS bare metal servers, where AWS provides their servers, and we install the software-defined data center stack on that. So as Andy mentioned, it takes 90 minutes to create a data center which is using VMware platform on AWS, right? So if you see here, I have one environment which I've built in US East, North Virginia, and let me go to that particular environment and see what is happening. So if you see here, this environment I've built is with a 3 dedicated host. This is not a multi-tenant solution. This is a dedicated single tenant for the customer. So nobody else uses this platform, apart from you, right? So this is so powerful, unlike the other public clouds, because the other public clouds, you have the noisy neighbor, right? If in case the security is not well architected, your noisy neighbor can sniff data, right? Trust me, can sniff data, right? So let's look at this, right? So this is the host which I've created, and also if you see, there is a message: maintenance has been scheduled, right? So if you remember, Andy just mentioned VMware Cloud on AWS is a data center offering where the server, that is your hardware stack, and your software stack, which is like VMware components, it's a managed service, which means if there is a hardware failure, you don't have to really worry about it. If there is a new patch, right? Let me give an example. Intel Spectre vulnerability. How many of you guys do you remember? So Intel Spectre vulnerability, when there was an issue, a customer had to go and update the patches right from application, operating system, virtualization layer, and the hardware stack. So for a customer size who's at least running 250 workloads or 250 VMs, it typically takes 3 to 4 months to do the complete upgrade of the stack. 3 to 4 months. What if we tell you VMware is going to help you upgrade the hardware and software stack, and you don't have to really worry about it, right? So that is the managed service which we're talking about. And if you really see here, so there is already a maintenance which is coming up, and all I got to do is I got a notification on my iOS device saying that there's a new maintenance update available when you want to schedule it. Isn't it that simple? And now, as an IT administrator or the operations guy, I don't need to spend sleepless nights on a weekend, because I hate doing that, while doing these upgrades. Because if something goes wrong, it can prolong for 36 hours, 48 hours. I'm sure you're gonna, love this feature, because as a support guy, I don't want to be, spending most of the weekends on doing the maintenance stuff, right? So if you look at the add-ons, right? So today you just see 2 add-ons. So as Andy mentioned, so we provide you a solution called HCX. This is a powerful tool for customers to accelerate their workload migration from on-premises to VMC within few days, right? So there were a lot of examples where customers moved within few weekends, within few weeks, within few months, right? So this is a powerful tool which is bundled, and it's not something like a paid service for you, right? The second service which is there is DR as a service, right? So as you saw, one of the key use case why customers consider VMC on AWS is, I don't want to invest a heavy capex on idle investment. But at the end of the day, DR is not idle investment. It's a regulatory compliance requirement. Though we say Singapore is safe and There are very few instances where I would turn on DR. But still, as a regulated entity, I still have to have. But for that, if in case if I'm a customer, if I'm spending CapEx, which is depreciating at a faster rate where I'm not at all using until I hit the DR button, right? But what if I can provide you DR as a service, where your CapEx is converted to OpEx capacity, where you're predictably running the DR tests once or twice in a year, and when the actual DR happens, you just instantly provision the clusters on demand, right? So that is the solution which we're talking about. And soon, you'll be seeing a lot of add-on services like Kubernetes as a service, right? Like, there'll be services for you to deploy VDI as a service. So those will be the add-ons, which will be more like PaaS capabilities for you, right? So without further ado, so let me go and show you a screen where you guys are very familiar with, right? So how many of you guys know this console? Awesome. So this is the vCenter console, right? And in this vCenter console, I see two vCenters. I see a vCenter-SDDC, and there's a vCenter 01. So I'm using a single pane of glass to manage two vCenters, where one of my vCenter is managing the on-prem data center, and the other vCenter is running in AWS. So let me prove it to you, because I don't think you believe me, right? So let me prove it to you. So if I go to this data center and I look at this particular server, the server model is EC2 i3.metal. Have you guys bought this i3.metal server anytime? I don't think so, right? So this is a dedicated host which is hosted in AWS data center, right? So let me show you the view of the on-premises. I'm sure you guys know about this brand, right? So Dell EMCs are grandparents who own us. so in this particular environment, I'm using Dell EMC hardware, which is running on-premises, right? So if you see here, it's quite powerful, right? I'm not using a different console. I'm not using a different tool to monitor, operate, run. My team, who's completely familiar in using vCenter or VMware management tools, they're able to extend the same tool to manage and provision workloads on VMC using vCenter, right? So now, quickly let me show you, because we've been talking about customers doing in weekend, in a month, migrations. Let me show you a simple demo where I move a workload which is running on premises to VMware Cloud and AWS, right? So if you see here, I'm going and switching to the vCenter of on-premises. So this is my on-premises, right? So I'm just going to show you. So this is the on-premises infrastructure. So let me just go and click on HCX. So HCX is a migration tool and also is a network extension tool, right? So a lot of customers, when they want to migrate their workload live, they're always worried about security and network posture of the workload. How do I move the security and network posture of the workload to VMC without having any downtime, right? So trust me, I'm going to show you a demo where, let me just go to hosting clusters. Let me just show you what is that workload which I'm running, right? Okay. So if you see here, I have the demo 01 workload, which is having this IP address, right? So when I move this workload, the IP address shouldn't change, right? At the same point of time, I also want to show you another virtual machine, which is also in the same environment on the same network, right? So let me just open the console of this machine and create a ping request to the other workload when it moves. So we'll see, whether there is any ping drop, any network drop, all those things, right? So if you see here, I'll start pinging. It's 213, and also if you see the latency here, it's less than zero 0.2 milliseconds, right? So let me start the migration process here. .cx, click on migration, migrate virtual machines. So I want to go and move demo 01. Okay, so let me just tell what exactly the posture should be, right? So I'm gonna say move this to okay, I have my own folder, so I'll just move it to there. So I'm just gonna say workloads, and I'm gonna share the information about what storage it needs to use, and I'm gonna change the provisioning option, and I have 3 different options. I'm gonna talk about it while I do this. So I'll use vMotion, right? So let me click on finish. Awesome. So I've just initiated the process, right? So let me see what I can do, right? So if I go back to my console here, you still see the latency as 0.1 millisecond, right? So let me switch to the console of VMC on AWS. So this is my console, vCenter console for VMC on AWS. And you saw, interesting options, right? So you should see the virtual machine appearing after the magic is completed, right? So you saw a couple of options while I was trying to migrate, right? So one was like, live vMotion. Second was bulk migration, and third was vSphere replication assisted vMotion, right? So let me talk about live migration. I'm sure everybody is aware of vMotion, right? So vMotion is just moving workloads from one cluster to another cluster in the same data center, but now with the capability of hybrid link mode, we can do vMotion of the workload live from one data center to another data center. Whether the data center is on premises or cloud doesn't matter, right? But how about second option? What is it? What if I have 100 workloads? I have an application tier. The application tier has like 50 virtual machines, and when I move this, I want this to be consistently moved, where I don't need to have DB application out of sync. So what I do is I select bulk machines and I initiate a switch. Right? There is also a third option where I can schedule. The replication is happening in the backend, and I can schedule on Monday, 8 o'clock in the morning, the virtual machine should actually come. Right? So the virtual machine should come and get powered up on VMC on AWS. Right? So that is what I can actually do with all these 3 options. Right? So let's look at the migration. So it's been like a few seconds. So let me see whether the migration is happening, right? So if you see here, it's still at 0%. I think while that happens, okay, it's just started, 12%. Okay, I think it should take less than few seconds. So what exactly is happening is the virtual machine continues to run on premises, right, without any kind of downtime. So think about this, use case. I do not have any downtime. I'm still able to move the workload, and the end users, be it a developer or be it a user who is, coming from internet and accessing your application, your complete posture of the workload is moving to a different data center without any downtime, right? So what you should see is when I move this workload to VMC on AWS, the workload latency should increase. The reason because I'm accessing the workload through ping from Dallas to North Virginia. So there should be some latency, right? So that is something I should see. So let's see. I think now it's making me nervous. Anyways, it's happening. Yep. So if you see here, it's increasing like 0.203, all those things. I think you will see like it'll suddenly spike up to 20 milliseconds. Right? So if you see here, so the virtual machine is completely moved, and the latency is 27.9 milliseconds now. So did you see any drop? Right? There was no drop. And let me see where the workload is running now. So the workload is now here. Right? So if I go to this particular workload, and the IP address is still the same. So this is possible with the layer 2 extension capability which you provide on VMC. Right? So now the best part is, you have already moved to VMC, right? What exactly are we doing with this co-engineering effort with AWS? Because you might think, okay, not a big deal. When I move this workload, it works. But how do I, modernize my application? How can I instantly consume some native services from AWS? So this is where, what we have done is, I'll show you a quick demo of some of the services which I'm using, right? So in this environment, I have a web app tier. So this web is, 231 IP, and there is another web instance. So let me just, go back to this web, take this IP address, and let me just do this. So I can actually access this application. It's working fine. So now I need a load balancer. So typically in traditional environment, what I would do was I would consult a third-party vendor, build a load balancer or buy a hardware appliance and install it, configure, and then start consuming it. But the concept of cloud is not about buying software. Concept of cloud is about buying consumption, right? You consume the product on day one. So that is the cloud service benefit, right? So let me show you how I'm able to integrate to some of the services which is built on AWS. So let me go here to EC2. Okay, so I'm just gonna log in. So this is my AWS console. I'm sure you guys are aware. So I'm gonna go to EC2. And what I'll do is I'll just go to load balancers here. So I have created one load balancer for my demo, right? So if you see here, so this is the load balancer, and let me see what is the listener configuration, right? So I have already created a listener configuration, and it is based on IP addresses. So if you see here, these IP addresses I just showed you of the same console, 231 and 232, right? So the same console, the same IP addresses I've added as application load balancer, where I'm consuming this service from VMC, right? So let me just take this load balancer's public IP or the public DNS name, right? So let me see whether it works, whether it's able to resolve. It's not working, right? The reason because I've put WAF. So WAF is a web application firewall which I've used to actually, show the integration of how I can filter some of the URLs, right? So the reason it is coming as 403 forbidden is because it is blocked by WAF. So let me go back to WAF and show you how things work, right? So if I go to WAF, right? So So if you see here, I've created a web ACL for North Virginia, right? So if you see here, I've enabled this one. So if I just, just for the demo purpose, if I just go and delete this, right? Okay, I'm just sorry. So if I go and delete this, I'm sorry. I should be able to delete this from web ACLs. Some of the entities. Okay, just a moment. Okay, I think I have got some permissions issue. So just a moment, I'll just take 15 seconds to review this. Okay. So anyways, I think I'll finish the demo here because I have some permissions issue with the WAF. So what I've done is I wanted to show you that I have blocked the URL with WAF so that I'm not able to access, and once I actually enable the rule, I can actually go and change it, right? So if you see here, I can actually edit the rule here, and I can say does not, right? So maybe once I do this, So I think there's some permissions issue which I've got, right? So anyways, so what I wanted to intend to show was, so with the integration of AWS services, I'm able to modernize my application delivery with the same SLA and with the same agility, right? So this is the best of both the worlds of AWS and VMware coming together and deliver the quickest way for you to migrate the services to VMware Cloud or AWS and also modernize the application, right? So with that, I would end my presentation. Thank you. Okay.
Thank you very much, Andy and Santosh. We are going to jump right into our next session now for the 5 o'clock. We have Dennis back to the stage with Amazon SageMaker Deep Dive for Builders.
Oh, sorry, I thought it's like 2 minutes. Right, okay. So, good afternoon. So I'm quite surprised. It's really late in the afternoon, and I'm not sure if you guys just had too much coffee or you're really interested. So, anyway, right. So I'll be going through. This is well, it's not quick, but there's a lot of information that I would want to present. So last year I did a similar presentation, so which was SageMaker. So I did an introduction to SageMaker, but after that, a year has passed, and there are a couple of things that are new, which I'm excited to discuss. It won't be that deep in a sense that because there's a lot that I would want to mention, right? So anyway, let's go on to it. But of course, what I would want to emphasize is yes, we do have SageMaker, but something that customers would want to know probably is AWS's approach when it comes to machine learning. A while ago, we were doing demos. If you went to the booth, you would have seen recognition. And then they were asking, are these features even usable? Right? So one point that I made is 90% of things that we do for machine learning are actually from customers. Right? So it's not like an engineer or an architect would say, wow, this looks like nice. Maybe customers would be able to use it, right? So 90% of the features or services that we release are from customer feedback, right? So that's one. And of course, probably a better picture to show like the innovation that we do, the amount of the momentum in terms of features, functionality, services, would be best described in terms, well, on the machine learning perspective based on this picture. So you can see that we have like multiple levels. So depending on your appetite or your skill level or however you'd might to call it, there are different services that you might be interested in. So at the bottom is if you're a hardcore ML practitioner, we can provide you with the frameworks. So may that be TensorFlow, MXNet, PyTorch, right? On the topmost, if you're not much into machine learning, but you're maybe just a developer who would want to invoke, I would want to know if there's a person or if there's a bird in this image, right? So you don't need to learn machine learning and all the algorithms and all that. You can just invoke the services. So services like facial recognition, identifying text using AWS Text Track, finding out the topics or topic segmentation if you run a document through it using services like Comprehend. There's also like Translate, Transcribe, etc. So we provide that at a higher level. But in the middle of that, if you're somewhere in between and you want to have the power of the different frameworks, but the automation that would lead you to more customized data models that is not provided with the high-level AI services, then SageMaker is right in the middle of the mix. Right, so going to SageMaker, so these are the typical tasks that you would probably do if you're doing an ML sort of workflow. So in each one of them, SageMaker would have functionalities to help out. Let's say in this case, collection and preparing in data, training and tuning models, and scaling it in the production environment. So don't worry about these 6 items because I'll be going through each one of them and then probably just mention, right, some things worth noting for the particular step in that workflow, right? Okay. Then of course, with all of these features, there's always customer backing, meaning they have attested and they have tried and used the product and they are really happy with it. Okay, so yeah, so in terms of innovation, there are a lot of things that we improve on and it will continue to grow in terms of new services and features. Maybe this is something if you have been using AWS for some time now, there's a constant flow of improvements into in the product. So SageMaker is part of that. Right, so for the first bullet, or the first item, we provide with pre-built notebooks for common problems. So basically, in most or a lot of ML algorithms, you would usually require labeled data, right? So anyone doing ML right now? Really? Okay, cool, right? So I think if you ask the people that are doing ML, one of the hardest things to find are labeled data. So if you go to the internet, you go to different websites, they will be providing different data sets. And it's very important that if you have that data set, it has to be labeled, right? So you must know if it's like for binary classification, a success or a failure should be there so that when you run using that data and then you put your tests, it should be able to use the labeled data as a training data set, right? But imagine if you're doing semantic segmentation, for example. So that's like 1, 2, 3 images. So if I can ask some of you how long for you to take like the mouse pointer and then label each one of the different images. Because let's say I would want to do an autonomous vehicle sort of model, right? So how long would it take for you to label this sort of data? Right, so let's make it simpler. What if you would want to box, like you want to box a bird or a species of a bird in a picture, right? Or you would want to do simple binary classification. You have a form, these are all the parameters, and then there's a yes, no, or a 1 and a 0 at the end. So it takes a lot of time, and it takes a lot of people to do so, right? So what we offer is what we call the SageMaker Ground Truths. So this came out a couple of months back. So what it does, it provides automation in terms of labeling. So you have your raw data, you have human annotations, and then the human annotations will produce the training data. So just imagine people helping you out when you're doing labeling. I did a TensorFlow model just a month back. I had to take 128 pictures, and then I had to box them one by one. Right? So I used, there's a Python tool that you can download through GitHub where you can do that sort of labeling, right? But then again, SageMaker Ground makes it a lot easier because apart from the workflow itself, it will offer you management of the workers, right? So the human annotations will go there. And then you have 3 different choices that you can do. One, right in the middle, you can assign your private workforce. Maybe it's your colleagues, maybe people in the company. So you write their email addresses, and then it sends out a link, and then they access the link, and they start labeling, right? So if it's just like boxing images, then yeah, that's what it would be doing. On the other side, we have Amazon Mechanical Turk. So in this case, these are still folks that are doing the labeling, but it goes through Amazon. Right, so if you're not familiar with Amazon Mechanical Turk, it's a service that we offer where you can go to Amazon Mechanical Turk if you want to earn some money, let's say, doing labeling tasks. And people can also go to you or to Mechanical Turk to look for people willing to do the labeling task. right? So you have your private workforce. You can go through Amazon Mechanical Turk, and at the same time, we have third-party companies offering this sort of service as well. So that takes care of the labeling portion in terms of workforce. Of course, if you have sensitive data, then probably you might opt for the private labeling workforce. But if you're working with non-sensitive or public data, then you can go either of the ones on the sides. Right? So key features, automatic labeling. That means if you've labeled a lot, you don't have to label them again. Let's say you're trying to label a bird or trying to put a box in the bird. The next time it comes up, if you've labeled enough of it, it will show you the boxed bird or image, and it's just up to you whether you accept it or not. Right? So that's for ground truth. And then, of course, for those who have already been using SageMaker, we do provide with we provide you with built-in algorithms, right? So one thing that I would want to mention is SG Boost. It's extreme gradient boost, so it's a very useful. If you're not sure which model to use, try to use XG Boost. If you're into topic modeling, let's say, you can use blazing text. Or if it's just simple linear regression, so we do have built-in algorithms for that one as well, right? So it's quick to get started without you having to go around and trying to create, let's say, or build your own algorithm. At the same time, if you feel that okay, so the built-in algorithms is not cutting it out for me, you have an option to go to the marketplace, and in the marketplace, you should be able to browse, subscribe to a particular model. And then, well, it's directly available in SageMaker. And in there, you should be able to get over 200 algorithms provided by other vendors. Like it could be dimensional mechanics, NIME, TIBCO, etc. And then you would see some algorithms. So let's say you're doing NLP and the built-in algorithm just don't cut it out for you. Then you can choose other algorithms available to the other providers. Right. So we went through ground truth, then we went through machine learning, and of course, in terms of, right, so infrastructure, right? So this is something that has stopped a lot of ML practitioners before because they're saying, okay, my model is good, I have the data, when I ran it, it ran for 5 years, right? So it's like they don't have the capability because I'm running an old laptop, right? They don't have the capability to be able to test, train a lot because there's just not enough compute power that's available to them, right? But of course, with the advent of AWS and cloud, now these highly spec'd sort of machines are now available at a click, right? So we will provide instances that offer GPU support, like in this case, NVIDIA V100 Tensor Core GPUs. And we provide Intel Xeon scalable processors as well. And something to note at this point is we provide Intel optimized versions of MXNet and TensorFlow, right? So that's something worth noting. So if you would want to, let's say, work on an optimized version of that, we provide that as part of the service. Okay, so in this case, they did training from the image net data set. They were able to get 93% accuracy in 18 minutes. So for those doing ML, so accuracy is a thing, right? So you have to make it as accurate as possible in the shortest time allowable. So in this case, they spent like $40 or $40 to reach 93% accuracy. Right? So, and then it was mentioned in the previous slide that they're looking for the P3DN in terms of the GPUs itself, but at the same time, bandwidth in terms of networking is very important, right? Because I've seen data mall some training and in the training job choke because there's just not enough bandwidth to move data back and forth. So we have instances that can go up to 100 Gbps connectivity. Right, so, okay, so you're able to label, you got machine learning and models, you have the infrastructure, but what if what you're trying to do is, okay, I want to develop a model, but I'm thinking this is not just something that will run on a single platform. I want to deploy it, let's say, on a Raspberry Pi or something that's inference on the edge, right? So if you're using MXNet, TensorFlow, and PyTorch, you might be deploying it into different platforms. So there's this challenge now that do I have to compile or build the model every time I have a new platform that's introduced, right? So that will not be necessary with SageMaker Neo, where what it does is you can train once and basically run it anywhere. Right, so the model, depending on where you'd want it deployed, would now be optimized, let's say if it's for Intel, Qualcomm, ARM, or any platform that you would want to run it into. Okay, so it's train once, run anywhere, and 2 times the performance. And the size is small. I've tried, so there was one time I was trying to train a model. I want the highest accuracy possible, but it gave me this huge file, right, that it was very difficult to deploy, especially if you're deploying into edge devices, right? So it comes at 1/10 the size of the original framework once you start to build the model. So it's lighter, but it's equally performant. Right, so one-click deployment. This is nothing new, really, but it sort of completes the workflow if you're doing, say, machine learning work, or in this case, SageMaker. So this is how it looks like in the console. So what you would see at the end of it is creating the model. So once you create the model, on this side, it can create an endpoint for you. So it does not stop just by you training it in, let's say, in a cluster or in your notebook or whichever notebook instance you're using. But at the same time, SageMaker will provide you with the infrastructure for inference. So there's training, there's inference, right? So that's something that you'll have to note. You don't necessarily need to have the same processing power when doing training versus inference. Like, for example, you may train, let's say, convolutional neural networks using GPUs, right? But there are data models that when you train, you need the GPUs, but when you're doing inference, you don't really need GPUs. It's CPU bound, right? So you have the choice to deploy it in different configurations. And of course, in the console itself, you would have access to those endpoints. Now, those endpoints, once deployed, managed by AWS, you can just invoke them via APIs. So you pass the right parameters, and it will provide you with the inference. Okay? So in terms of, let's say, deploying it into production, right? So now, okay, I think I was able to train my model, but in terms of cost, then suddenly you found out that training is 10%, but my inference cost is in fact 90%. 90% of the cost that I'm incurring, right? So the question now is, how do I bring down that cost? Okay, so in this case, challenge mostly is, okay, you got this instance, but you got something big, but it's underutilized. Now, you might know, you can always pick something smaller. But the thing is, since your load is highly variable, let's say a lot of inference is happening maybe, 5 p.m., and then it goes down, and then it goes up. So there are instances where probably, or well, most probably, the hardware that you provided is just too much for the inference that you meant it to run, right? Hence, high cost, but low utilization. And the thing is, there's no one size fits all. Okay, this instance should take care of all my problems. No, unfortunately, it's not. So how do we optimize that? We have what we call the Amazon Elastic Inference. So in a nutshell, what it does is, remember I mentioned earlier, you pick your instances when you're training. Let's say I pick P3 instances to train, and then I use C5 instances, which are compute-based instances, when I do inference, right? What this can do is, instead of you doing training, let's say, on a cluster of P3 instances, you can use the local instance, so not invoking a separate infrastructure, and attach an elastic inference into your instance, giving you extra compute power for training. You can put it in, you can take it out. So you're no longer working with a fixed capacity in terms of instance size. So that means if you don't need it, take it out, the costs are lower. If you need it, then attach the EI or the elastic inference, and then you will get charged for that, but only for the time that you're using or you're doing it for training. Right? And that's also true for inference, right? So you can, let's say in low loads, the CPU is enough, but if there's like you would require extra power, then you can introduce EI into the inference, and then it should boost your inference. So like in this case, as I've mentioned, you can have your EC2 instance that you're doing, and then you just do local mode. So anyone using Jupyter, have tried using Jupyter notebooks? Right, so I see a lot of people using Jupyter notebooks, and when you invoke, let's say, a training job with SageMaker, what you usually specify is the command to train it, and then you specify the instance type. So normally, you would like maybe put P3 something something or MX or M5 something something. There's an option that instead of putting the instance type that will be spawned or spun up to do the training, you can choose local mode. When you choose local, it uses the compute power of the instance that you're running on. So just to explain, in a typical Jupyter notebook installed on your laptop, whenever you do training, you use the laptop. With SageMaker, you can use a local laptop and then invoke a SageMaker, but the training is done outside of your laptop. That can be done. So hence, you get the flexibility of getting larger instances. But what if, no, I want to use my local notebook? Right? I don't want to run it in a separate P3 instance because they might be expensive. And this is not a production workload yet, so I can opt to use local mode, but attaching an EI into my local instance, hence giving me a boost whenever I'm doing test training. Right? So that's one on the training side, and of course, that's true for elastic inference as well. So you'd be able to scale that. Right? So if you feel that you're getting a lot of charges or the costs are high, if you're doing inference or even training, look into elastic inference. Okay, so model support, of course, it works for TensorFlow, MXNet, and well, Onyx is underneath also MXNet. And it's available if you're using one of the deep learning AMIs that we provide. Right? You can also download it if you want via S3. Okay, so that completes the 6 different, I would say, steps or tasks if you're doing typical machine learning, right? So, but then again, machine learning is a highly collaborative sort of process. So it does not involve just you sitting in a laptop and doing your ML. It has to tie up to something else, right? So there are a lot of interactions that are happening. So that can be deployed, let's say, to devices or IoT, etc. That could be inserted into, let's say, a relational database. Like, for example, we're working, we have customers that try to do ML to get topics, doing topic modeling from, let's say, corpus data or text data that they get from the library. And they use the topics as attributes for the next regression algorithm to determine the outcome that the document is meant for. Let's say proposals. You can have lots of proposals and you would want to know if the proposals are accepted or not. So that's binary classification, right? So you get the text from the proposal, run topic modeling, get the popular topics in it, feed it into linear regression or binary classification. And with that, well, it's like ensemble in one sense. You should be able to hook that up to other systems in your company, right? So other things, you can do SageMaker search if you want to experiment management, and also step functions. So if you would want to chain, let's say, different models, and you would want them to be invoked in a serverless fashion, we have AWS step functions, which is AWS Lambda underneath as well. And then it can integrate with Apache Airflow, right? So this would supplement the task that was described earlier using SageMaker. And at the same time, in SageMaker, in fact, if you run or launch a notebook in SageMaker, there's an option where you can specify a repository. If you're keeping stuff in a repository, let's say that's where your project is, you can specify that and it will automatically clone the repository into your notebook instance. Okay? Right, so that's a lot of things. As I've mentioned, it's like, a crash list. So I hope in further presentations we would have like deeper discussions or the different topics in a deeper form. But again, so what if this is like a segue in one way, right? So you have the data, but you don't have enough data. So on one end, upper left, your upper left. Oh no, sorry, lower left. If you have not much data and then the complexity is not that huge, then you can probably use unsupervised learning. If you have complex decisions, and then that would and a lot of data, you can do supervised learning. But what if you need to do complex decisions, but you do not have enough information? So that's where reinforcement learning comes into play, right? So in an RL or reinforcement learning environment, so you sort of come up with a representation of a world, and then there are conditions, and there's interaction, and then there's the dynamic updates on the decisions that you make. Imagine creating a game, right? You have a character, it's RPG, and you want to level up from level 1 to level 100, right? So if you kill one small monster, it will give you 10 experience points. If you kill a big monster, it will give you 100 experience points, for example. So you get rewards every time you kill a monster. But at the same time, depending on the sword or the armor that you're wearing, right? So the state that you're in, it will have an effect whether you effectively kill the small monster versus the big monster, right? So those are things that would comprise, let's say, an RL environment. So those of you that are interested in creating bots or something for gaming, it's one way to to do it, right? So RL models learn how to make decisions and to accomplish tasks. So if you're familiar with not just games, autonomous vehicles, for example, right? So if you would want to teach a car how to drive given certain conditions, then RL is the way to go. Anyone know what Markov chain is or Markov learning process? Cool, right? So similar concept. So it relies on the current state. You don't have to have a lot of historical data. Remember earlier I mentioned you need a lot of labeled data to train your model, right? But if you don't have that, and these are the cases that it falls into, you can do reinforcement learning, right? So we have, I'm not sure anyone has heard of Deep Racer, where you have a car that goes around the track, and then you'll have to train it to run as fast or to go as fast as it can without hitting the walls or something or getting derailed, right? So it takes a lot of trial and error to be able to do that, but this is the process and this is exactly what it's doing. Right, so achieve outcomes and not decisions. So probably I'm discussing reinforcement learning. So Dennis, where are you going with this, right? So the environment is there. You create the environment, you create the scoring function, and then you run the RL algorithms. And this is extremely complex and quite expensive to do, to be frank, right? So where I'm heading to is we have SageMaker RL. Basically what it does, it gives you a lot of features and functionalities if you want to do reinforcement learning, right? So in terms of features and functionality, right in the middle, if you're into robotics, right? So teaching a mechanical arm to do things based on state, right, rather than historical data, then Amazon SageMaker RL is there for you. So it supports MXNet, TensorFlow, Intel RL Coach, so in conjunction with Intel Scalable CN processors or Skylake, right? And RL Coach, you should be able to optimally train your models or to run SageMaker RL, right? So SageMaker RL is a beast on its own, meaning it warrants a whole presentation, in fact. But I just inserted it under managing environments for training. So I guess going back to the capabilities of ML, I've described a lot of the tasks. I've described a lot of the features that you can use. And then just going back to different things, there's ground truths, there's Neo, And then, of course, on the high level, if you're looking into comprehend medical, so we do have a lot of those. You just need to find the right service that's right for you, right? Because I have seen a lot of, let's say, developers who are afraid to venture into machine learning because they're saying, I don't know TensorFlow, I don't know MXNet, I don't have the statistical or mathematical background to do machine learning, right? So that's why we provide high-level AI services. But then again, researchers will say, no, but they don't have enough domain expertise. If you need domain expertise and you need data and you need a lot of customization, then you can always go, like in this case, ML services with SageMaker, or you can do frameworks and infrastructure as a platform if you're a hardcore ML practitioner. But for the developers who just would want to know if there's a person in the picture, then you may not need to go really deep, right? So that's it. But one scenario that we usually do, you can choose. It doesn't have to be one or the other. Like, for example, you can have a camera, let's say a Raspberry Pi. It's a very low-power device that will detect, let's say, if there's a person, right? Once you detect the person, so instead of you embedding a data model that detects who the person is in the picture, you can just have that device detect the person, get the frame, send it up, and then run another inference that given that there's a person to identify who the face is. Right? So that's a two-step or multi-step sort of inference so that you can mix and match the different services that would apply to your particular use case. Right? With that, there are a lot of resources that you can go to. Right? So there are a lot of, even outside of AWS, if you want to learn machine learning, data science, and all, a lot of resources available. And what I would recommend is don't be afraid to experiment a lot, because once you go through all the theoretical courses, you'd find out that, okay, so where do I start in terms of tooling? We provide the different layers for you as described earlier. Right? And with that, I think that's the last slide. And thank you again for staying this late. I know this is the last session. And thank you again.
Thank you again, Dennis. And like he mentioned, that was our last session for today. So just a final reminder to please submit your feedback for any session you went to today in the app. And all of the devices for the content will now be at the exit, so you can tap your badge on any of the content you would like to receive. And starting at 5:35, we are hosting a cocktail reception in the expo hall, and we'd like to invite all of you to join. So thank you so much for attending today. Enjoy the rest of your evening.